All right, so we want to look at a way of classifying data and to find patterns in the numbers, the sets of numbers and the data that we're going to see. And so what we're going to do is we're going to work on, let me show me here, we're going to work on something called frequency distributions. My lovely crayon writing here, frequency distributions. Picked up a new pen for my tablet. It's overly sensitive. I'm trying to adjust it down. But frequency distributions. And the root here is frequency. When something is frequent, we tend to think of music where we have waveforms. And the frequency is how many waves pass a certain point in a second, right? So the A in music is 440 hertz or 440 waves per second. And that's a frequency. For our definition, it's going to be how many things in a window, some window. Right, we look out, and the frequency is how many things we see that fall into a particular bucket or bin. Bin is the word that we tend to use in statistics. We bin data is what we'll call. Did my thing get cut off here? What is happening there? I somehow made the word window look really weird. There we go. The pen's a bit better. Whatever I did there, that helped the pen a bit. So we'll take it. And so let's start by kind of thinking of what we want to do. And so frequency distribution, I'm going to use a generic one to describe its parts. And I'm going to follow the ones in the book for a bit. We're going to look at some different data examples as we go on. And what we have is we organize data into classes or intervals. The book is going to use the word classes. I tend to use the word intervals. If I switch them back and forth, even in the definition of the book, they say classes or intervals. And then the frequency, which gets a curly F. And so classes are a range of numbers. 1 through 5, 6, oops, get back. I don't want you. Go away, go away. That's the pencil I've been using. Nope, that's not. Here. Where is my pen? Big, smaller, small. There we go. 6 through 10, 11 through 15, 16 through 20, 21 through 25. I'm going to scroll this up. Here's my classes and frequencies, 21 through 25 and 26 through 30. And what these have is they have parts. And I'll put the frequencies over here that the book gives. 8, 6, 8, 5, and 4. And so what happens is the data falls into these values. And this is telling me I have 5 pieces of data from some larger sample of data that their values are between 1 and 5 inclusive. It can be 1, 2, 3, 4, or 5. This tells me I have 8 pieces of data that the values are between 6 and 10. Inclusively, 6 or 10 can come in. And so what we tend to notice is each one of these classes, 1 through 5, 6 through 10, 11 through 15, has a lower class limit and an upper class limit. And so 1 is the lower class limit of the first class, or the first interval. 5 is the upper class limit for the next for that interval. 11 is the lower class limit for this one down here. 15 is the upper class limit. And so we have a lower number and an upper number of values that we can put in here. And then we have the frequency count. Now we'll notice that if I take 6 minus 1, I get 5, right? Take 6 minus 1, I get 5. The lower class limit here and the previous lower class limit. If I take 11 minus 6, I get 5. If I take 16 minus 11, I get 5. If I take 15 minus 10, I get 5. The difference between these upper class limits. And this value 5 is called the class width. And the class width is the difference between adjacent class points. So if there's a midpoint, which we'll learn later, the difference between two classes' midpoints will be the class width. For right now, we're looking at adjacent limits. The difference between any adjacent upper limits is 5. And that's the width of the data, or the class width. And so these help us work our way together. And so let's build one of these with data. And so there's some rules we're going to follow. We're going to, 1, decide on the number of classes to use. Now there is, this is a trick. It's part of the art of statistics, is figuring out how much to divide your data in and still see patterns. So for right now, the problems tell you the number of classes to use. There's a rule that says however many pieces of data you have, right? The data, you want 2 to the k to be the first thing greater than your data. And use k as your number of classes. We really won't look into that until much later. So for now, just use what your book has. There's many different formulas statisticians use depending on what they know about the data. We want to see data first before we make some of these deeper decisions. And especially once we start using Excel and other ways of visualizing it, we can leave this rule for now and just go by what's in the book. Next thing we need to do is we need to find the class width. And we do this by taking the range of the data. Now the range is you find your minimum, which is your lowest data value. And you find your maximum, which is your greatest data value. And your range is your max minus your min. And so the width you will need to construct your bins is the range divided by the number of bins, or number of classes. I keep calling them bins or intervals. The number of classes you're going to use. You always round up. And the reason for that is we need to give enough room for every piece of data we're going to use. So if I do this calculation and I get 3.6, that rounds up to 4 normally. If I get 3.2, it still rounds up to 4. We always need the extra space to make sure that we have room for every piece of data. All right. And then the next thing we do is, right here, we set the lowest class the lowest class's lower limit to the minimum data value. And then we add the width to find each class's lower limit. One rule is classes cannot overlap. Classes cannot overlap. And then we repeat this for the upper limit. Then we put our data into the classes, usually using tally marks. We tally the data. And we'll tally the data up. Scroll down a little bit more. And then count it up. Count up the tallies. So let's do one of these, and let's do it piece by piece. I'm going to use the data that the book uses, which is here. Let me brighten up the screen a little bit here. All right, and so this is slide 11 from chapter 2, section 1, and we have 30 pieces of data. And those 30 pieces of data is this range of numbers. Now there are patterns in this number set, and from this pattern we should be able to see some things that are happening with the numbers. And so, but looking at it now, these patterns don't pop to the eye. And so the frequency distribution will help us to get these numbers popping out for us. All right, so let's use this and do some things with this here. So if you have that slide out and we look at the numbers, the smallest number is 155. So the minimum is 155. And the maximum is 405. And the book asks for 7 classes. So our class width is going to be (405) minus 155 divided by 7. So 405 minus 155 is 250. And 250 divided by 7, let's see, 7 goes into 25. 3 times, 4 left over. So 7 goes into 25 3 times. 25 minus 21 is 4. Goes in 5 times, which is 35. So that's 5 left over. You go into 57 times. That leaves me with 1 0 goes 1. And this continues on. Sorry, doing my division in my head here. I know I have the answer on a piece of paper. I should pull it. Well, we always round up. And so our class width is going to be 36. And so we want a class width of 36. All right, so what I'm going to do here is I'm going to number down just so I know that I have 7 classes. I don't want to run out of space. So I'll leave my width up there as 36. Now again, we want to refer to the data, 6 and 7, and so my classes. And so I'll start with my lowest class at 155, right? Because that's my minimum piece of data. And what I'm going to do is I'm going to add 36 to 155, which gives me 191. I'll add 36 to 191, I get 227. So I was surprised at my answer. And I add 36 to 227, I get 263. And so see how I'm using the class width to create the next lower class coming through. And then if I come here, 263 plus 36 is 299, 335, and 371. And so there are all my lower class limits. Just put dashes because I'm trying to keep track of each classes. Tend to, when I write here, I want to keep my line steady. So my upper class limit, well, if I can't have a gap between these and they cannot overlap, the number this has to be is 190. And now I can, then in this one has to be 226. All right, one less than the lower limit up above, so this is 262. And one less than the limit below, so this is 298. This is 334. This is 370. And then in here I'll add my 36 to, and I get 406. Notice that my maximum was 405. I have a space of 1 left over. And that's because of the rounding up. If I would have rounded down, I could have ended up with 404, and I wouldn't have had room for my maximum. So now I come back over here to the data. And I go, okay, 200. That goes into this class here. And so I put a tally mark down for where 200 goes. And I go back to the data again and I go 239. Well, that comes over here, and 239 is in this here. And I work my way through each piece of data, putting a tally mark down. So I'm just going to read through each piece of data. I tend to mark them off on my list as I go through. And so I have my data written down here. So I will work my way through each number and I'll put a tally mark down. If I flip to the right page, I flipped it upside down. Where did I put that? There we go. So my first number was 200, my next number was 239, that's in there. My next is 155, that was the minimum, so I have a tally mark there. Then 252 here, 384 here, 165 here, 296 here. Notice how each value follows within the class. 405 is within those. 303, 400, 307 in here, 241, 256, 315, and so each piece of data falls into a bin. In astronomy, we call this binning our data. We put things into bins. 317 goes there, 352 goes there, 266 goes here, 276 goes here, 345 goes here, 238 goes here. 306. 290. You should be following along with the data. I'm now on 271. 345. 312. 293 here. 195. 168 and 342. And so we see that we've put all the data into different bins. And so now we're going to count up the data sets, the tally marks we have, and get an idea of how often our data is appearing in places. And so what I'll do here is I'll put my, oops, get my orange back here again. Do is we'll come over here, we'll put an F here for my frequency column, and there were 3 here, 2, 5, 6, 7, 4, and 3. And we can visually see some things happening already. There's a grouping of large numbers here, where it's smaller here and here. So there's some grouping of numbers here. Now if I add up my frequencies, and so the notation we'll use for this is the sum of all the frequencies. And so if I add these up, 3 plus 2 is 5, 5 plus 5 is 10, 10 plus 6 is 16, 16 plus 7 is 23, 23 plus 4 is 27, and 27 plus 3 is 30. Whoops, I hit the wrong pen again. Let me get back to my other one. There we go. Keeps wanting to do a paintbrush. 30. That was the number of pieces of data I had. Each piece of data has to go into a class. So the sum of everything in my classes has to equal the number of things in my data, or n. Right? Or little n if it's a sample. And so this is how we create a frequency distribution table. All right, in the next lecture, we're going to look at some more details that we can get out of this.